a hot sunny afternoon. Outside, there is a steel chair and a wooden chair. If you were to sit on one, which would it be? You wouldn't want to sit on the steel chair. Why? So hot, right? Since the chairs were exposed to the same quantity of heat from the sun, and not that more of the heat favorably chose the steel chair and a few chose the wooden chair. Why is the steel chair much hotter then? Yes. Steel is a better conductor of heat than wood. Correct. But then, that only means it absorbs, transfers, and spreads heat internally much faster than wood and has nothing to do directly with temperature increase. In fact, even if wood is as good a heat conductor as steel, it will not still be as hot as steel. So then, what is technically responsible for this rapid increase in the temperature of the steel chair? Well, nice meeting you, and welcome to another exciting episode of Demystified Physics with Master K. Well, what is specific heat capacity? Specific heat capacity is a coinage of three words: specific, heat, and capacity. Specific there means per kilogram, and heat capacity means the ability of a substance to store heat energy. Semantically, it can be defined as the quantity of heat energy required to increase the temperature of 1 kilogram of a substance through 1 degree Celsius or Kelvin. In other words, it is the amount of heat energy needed to be absorbed or stored up by 1 kilogram of a given substance to make it 1 degree Celsius hotter. Consequentially, a substance with a low specific heat capacity requires just little heat energy to increase its temperature, while a substance with a high specific heat capacity needs lots of heat to increase its temperature. A typical example of this is wood and steel. Steel has a low specific heat capacity of about 0.5 kilojoules per kilogram Kelvin, and wood has a high specific heat capacity of about 2.4 kilojoules per kilogram Kelvin, almost 5 times higher than steel. This implies that every 0.5 kilojoules of heat absorbed by 1 kilogram of steel will make it 1 degree Celsius hotter. Meanwhile, wood requires 5 times that much heat to attain just 1 degree Celsius. To understand this better, let's consider this simple experiment. Let these tubes represent a 1 kilogram piece of wood and a 1 kilogram piece of steel outside in a hot sunny afternoon. As we can see, the length of the tubes is proportional to their specific heat capacity, and also the red content in them represents heat energy absorption from the sun, of course with the assumption that it is steady. So let's see what happens. 0.5 kilojoule of heat absorbed, the steel is 1 degree Celsius. 1 kilojoules, the steel is 2 degrees Celsius. 1.5 and the steel is 3 degrees Celsius. But the wood is still absorbing a lot to get to just 1 degree Celsius. At last, the wood is now only 1 degree Celsius after absorbing the same amount of heat as the steel. So here is a question. Our main point of interest here should be the specific heat capacity of water given. 4.2 kilojoules per kilogram Kelvin means that 4.2 kilojoules of heat needs to be supplied to 1 kilogram of water to increase its temperature by 1 degree Celsius. But in this case, we have 2 kilograms of water, therefore 2 times heat is needed, and also an increment of 6 degrees Celsius, therefore 6 times heat is also needed. So all in all, 4.2 times 2 times 6 equals 50.4 kilojoules of heat is what is supplied to the given water to increase its temperature from 9 degrees Celsius to 15 degrees Celsius. Easy. Well, the questions sometimes aren't always as easy as this, but now at least we know how specific heat capacity works and we have a generic idea of how to analyze specific heat capacity questions. Watch my upcoming specific heat capacity series videos for more insights. Follow me on Facebook at Demystified Physics and Maths, and subscribe to my YouTube channel for more exciting content like this. Till next time, bye bye.